The familiar stars we see every night in our sky seem infinitely far away and completely alien to us. Like otherworldly entities existing in some higher dimension than the one we experience from our perspective on this tiny, twirling mass of rock and water we call home. Yet, we are connected to them, and they to us. Everything in the known universe consists of the materials that result from stellar birth, death, and resurrection, even humans. It's no wonder we like to posit that we may be able to do the same. To identify and strengthen the human connection to the stars, for thousands of years we have assigned names and sometimes mythological personas to our cosmic neighbors, even going as far as to implicate them as forces affecting our daily lives. One example of ancient mythology reaching out to us from the literal heavens is the Greco-Roman story of Castor and Pollux, the twins who make up part of the Gemini constellation. They were born to Leda, queen of Sparta, but Pollux was the immortal son of Zeus, who had seduced the queen in the form of a swan. The brothers were the best of friends and had many adventures, including joining the Argonauts in the quest for the Golden Fleece. They were the patron deities of sailors, bringing fair winds and protection from death at sea. Ancient seafarers would invoke the twins during turbulent events. Apparently, electrical storms can cause ionized air molecules to give off sparks, a common phenomenon called St. Elmo's fire. These sparks were often mistaken for a sign that the twins had appeared on the ship's mast to guide the crew to safety. Since Castor was mortal, and a life of adventure and heroism inevitably leads to death in battle, Zeus granted Pollux his mournful wish of shared immortality with his brother and transformed the two of them into the constellation Gemini so that they could be together forever. Pollux, otherwise known as Alpha Geminorum, is the brightest star in Gemini. An orange giant about 34 light years away, Pollux only appears to be next to his brother Castor from Earth's perspective. Castor, or Beta Geminorum, is actually a multiple star system about 51 light years away. Regardless, since Pollux is extremely visible to the naked eye and lies along the zodiac, its predictable rising and setting have been a guide for mariners for centuries. Sailors could also use the line of alignment between the pair to orient east to west before compasses were invented. The utility of the pair's visibility and reliable position in the sky does seem somehow tailor-made for sailing, doesn't it? Here's a diagram of the Gemini constellation with Castor in gold and Pollux in orange highlighted. The dashed cyan lines show how the main stars were connected to form the twin figures. Castor and Pollux at the top are the heads, with the other stars forming the bodies. For sailors, these bright paired stars were an easy sky marker for orientation and identifying the season. Now, let's sail away from the ancient Mediterranean and its superstitious sea folk and rocket ourselves into outer space to investigate the real Pollux. What's his deal? When was he born? How big is he? How far away from Earth? Is he anything like our sun? Does he have planets? If so, are they habitable? Most importantly, when and how will this stellar icon finally cease to exist and be reborn into a new stellar body? And what can this cycle of birth, death, and resurrection in Pollux reveal about our branch of the universe? So, how far away is Pollux from Earth, and how do we know this? We know Pollux's distance because satellites like Hipparcos in the 90s and Gaia in 2013 measured its parallax angle with high precision. The geometry gives us a direct distance of about 34 light years. However, one could guess by eyeballing it since it is visible to the naked eye and shifts slightly in position about every 6 months. According to Stellarium, Pollux is located at 7 hours, 46 minutes, 53.5 seconds, plus 27 degrees, 57 feet, 48.7 inches. Right ascension is like longitude, but is measured in time units relative to the vernal equinox. If a star's right ascension is 7 hours and 46 minutes, it will cross your local meridian 7 hours and 46 minutes after the vernal equinox point does. A star's magnitude is its visible brightness. Stars have an apparent and an absolute magnitude. The apparent magnitude of a star is how bright it appears from the point of view of Earth, and depends on both the star's intrinsic brightness and its distance from us. Lower numbers indicate brighter objects, thus negative values indicate extreme brightness. The absolute magnitude is how bright the star would look if it was about 33 light-years away, which removes the effect that distance has on a star's visibility and brightness. Pollux has an apparent magnitude of plus 1.14 and an absolute magnitude of plus 1.09 and a distance of 33.7 light-years. Pollux appears bright in the night sky because it's relatively close and has strong intrinsic luminosity, about 43 times the sun's luminosity. The sun's apparent magnitude is minus 26.74 and its absolute magnitude is plus 4.83. The sun looks blindingly bright simply because we're only 1 astronomical unit away. If you move the sun to 10 parsecs, or 33.7 light-years, it would appear as a fairly modest star in the sky. So, to compare Pollux with our sun, it is intrinsically brighter than our sun based on the fact that its apparent magnitude is so highly visible, even though it is 33.7 light-years away. Our sun looks brighter because we're so close to it. Stars have spectral types that depend on their temperature, classified from over 50,000 K to less than 3,900 K, which are those cool red, low-mass stars that we see most often, our friends the red dwarfs. Pollux's spectral type is KO3, a cool orange giant, with a temperature of minus 4,800 K and a mass 1.9 times the mass of the sun. He's a post-main sequence star in a later stage of stellar evolution. Our sun, for comparison, is a G2, hotter, younger, and still burning up that hydrogen core in the main sequence. Yet, youth isn't everything when it comes to real stars. Pollux is cooler, larger, and more luminous than the sun. Pollux is a KO3 orange giant, meaning it has already exhausted the hydrogen in its core and evolved off the main sequence. Its mass is roughly 1.9 times the sun's, which means it burns through its fuel much faster. Stars with about twice the sun's mass typically spend only a few 100 million years on the main sequence before swelling into a giant. Pollux is in that post-main sequence phase now. By contrast, the sun is 4.6 billion years old and is still in its main sequence, with roughly 5 billion years of stable burning left. Both stars will die the death of a red giant, transformation into a white dwarf. For perspective, Pollux is what the sun might look like in 5 billion years. Although there are some similarities between Pollux and our sun, habitability is not one of them. Because it is expanded and brightened dramatically to more than 43 times the sun's luminosity, its habitable zone has shifted farther outward than during its main sequence phase. However, there is one confirmed exoplanet orbiting Pollux named Pollux b. Pollux b, a gas giant with about 2.3 times the mass of Jupiter, was discovered in 2006 and has an orbital period of 590 days. Even if Pollux b was not a gas giant, it would be too far outside the habitable zone to host life. While there definitely won't be anyone to contact out there, what was most surprising about this whole project was that I found out that if I did want to send a message all the way out to Pollux, radio is still the most effective way to attempt to communicate with possible life in places that far away. In fact, we already have transmitters and dishes capable of focusing energy directly into specific areas of space. It's what SETI has been doing for years. So, Pollux is an old giant with a deep connection to the Earth from the perspective of the first conscious humans, as a guide, protector, and symbol of brotherhood. What makes Pollux scientifically compelling today is that by studying it and others like it, we can predict what could happen to our sun and its nearby bodies when it finally enters its own red giant stage, thus ending the long and magnificent age of our solar system and everything humanity ever hoped for and accomplished in a very big bang, when our red giant sun collapses into a tiny white dwarf and begins a new life cycle as a hot young star in our vast cosmic firmament.